Hello everyone, this video is about the inverse of a function. The original function is called f of x usually, or sometimes g of x, h of x, and the inverse of f of x is f inverse of x, g inverse, h inverse. For the domain we use the symbol x, for the range we use f of x, and for the inverse we use f inverse of x for the range. Finding the inverse of a function algebraically. Step 1, use y, replace f of x with y. Step 2, swap the x and the y. And step 3, you solve for y. In this case, we switch sides and subtract 3 from both sides, divide both sides by 2, we get x minus 3 all over 2, and we use f inverse of x. Swapping domain and range. So the domain is from -2 to 2. We can calculate the range, which is from -1 to 7. The domain of the inverse is just like this, so exactly the same, but we use x instead of f of x. And for the range, just like this, from -2 to 2, but we use f inverse of x instead of x. Finding the inverse of a linear function graphically. For example, we have the blue function here. So this is the original function, the blue function. From -2 to 2, that's the domain. The range from -1 to 7. If we plot the points, we have this set of points: -2, -1, -1, 1, 0, 3, and so on. So we have this straight line. And for the inverse, we just swap the x and the y values. We have -1, -2, 1, -1, 3, 0, and so on. So we have this red line, and they are actually a reflection in this y equals x line. So this is the mirror. The inverse of a quadratic this time. So the red function is the original, y equals x squared. The blue function, I mean it's not a function actually, the blue curve is the inverse, and again they are the reflection in this y equals x line. Since x equals y squared is the reflection in the line y equals x equals y squared is the inverse of y equals x squared. However, x equals y squared, or y squared equals x, or y equals plus minus square root of x is not a function. So the resulting reflection here is not a function because it doesn't pass the horizontal, it doesn't pass the vertical line test. Here we have two intersections, so it fails the vertical line test. So we say the inverse is not a function, or the inverse does not exist. This makes sense because the original function, the y equals x squared, is not a 1-1 function because it fails the horizontal line test. We have two intersections. So the inverse does not exist if the original is not a 1-1 function, and quadratic functions are not 1-1 functions. But what if we use only some part of the quadratic function? Domain restriction is when we use only some part. So this is the original y equals x squared without domain restriction. So we use the natural domain, continues forever in this direction and in this direction. This is again not a 1-1 function because we have two intersections here. It fails the horizontal line test. So if we restrict with the domain such as like this, we only use this part on the right. Now this curve passes the horizontal line test. Now it is a 1-1 function, and now we have an inverse. So we can restrict the domain, we use only some part of the curve. The largest domain restriction of a quadratic function is when we use exactly the half left or the half right of the function. So this is in the vertex form. We have the h comma k, the vertex, or in general form we can find the x value of the vertex using minus b over 2a. So if the domain is x is bigger than h, the h is the x value of the vertex here. This is the largest possible domain if we use bigger than, x is bigger than something, x is smaller than something, then we use the left part. Finding the inverse of a quadratic function algebraically, first step, we use completing the square to find the completed square form, and then we replace f of x with y, and then we find the inverse by we can swap the x and the y, and then we solve for y by switching sides, add 8 to both sides, divide by 2 both sides, take the square root of both sides, and minus 1 both sides. So this is what we get. So we have plus minus, and we have to decide whether we have to use the plus or the minus. You can do it this way. Step 3, plug in a random x value in the domain. Here the domain is x is bigger than 1, so you can plug in anything bigger than 1, for example 2. If you replace this x with 2, you get 2 times 2 plus 1 all squared minus 8, which is 10. This means f inverse of 10 is 2. Now we can check whether we have to use the plus or the minus sign by plugging in 10 here to this x. 10 plus 8, 19 over 2, 18 over 2, 9, square root of 9 is 3. So remember, we gotta get 2 for the f inverse of 10. So we have to use the plus because 3 minus 1 is 2. So in conclusion, the inverse is the positive square root of x plus 8 all over 2 minus 1. And now to find the domain and the range. Let's say this is the domain, we can calculate the range. So the range is bigger than 1 because we only use this part to the right. X is bigger than 1, and the domain of the inverse is therefore bigger than 0. The range of the inverse is therefore bigger than 1. That's it. I'll see you again next time.